Welcome to the Level 3 video on differentiation and integration. Today we're going to be looking at integration by parts. So the formula for integration by parts is the integral of u v dash dx equals u times v minus the integral of v u dashed dx, where dashed is of course d by dx and u and v are both functions of x. And this actually isn't too hard to prove, so we can go ahead and look at the proof. If we integrate both sides of the product rule, and use what we call the fundamental theorem of calculus, we can prove integration by parts just using the product rule. So let's familiarize ourselves with the product rule again. So it was the derivative of the product uv equals u times dv by dx plus v times du by dx. Now, if we go ahead and integrate both sides of this, between a and b, then using the fundamental theorem of calculus, we just get that u and v between a and b, of course, is equal to the integral from a to b of u times d by dx of v with respect to x plus the integral from a to b of v times d dx of u times dx. And then rearranging that, and we're just rearranging it to find this bit. So the integral from a to b of u d dx of v dx is equal to uv between the points a and b minus the integral from a to b of v times d dx of u dx. And that's the formula. So that's the proof completed. Now we're going to look at an example quickly of integration by parts. So using integration by parts, evaluate the following definite integral. And that integral is the integral of x squared times e to the x with respect to x. And our solution to this, we identify u to be x squared and dv by dx to be e to the x, then du dx is going to be 2x, and v is going to be the integral of dv by dx, so just e to the x. Then we substitute this all into the formula. So the integral of x squared e to the x dx is equal to x squared e to the x minus 2 times the integral of x times e to the x dx. And then we have to use integration by parts again. So again, we identify u to be x and dv by dx to be e to the x. So the derivative is 1 and the integral is again e to the x. Then again we substitute this into the formula. So the integral of x e to the x with respect to x is x times e to the x minus the integral of e to the x, which is e to the x, x minus 1. Then we substitute it back into the original integral. So we have the integral of x squared e to the x with respect to x is x squared e to the x minus 2 lots of, because of the 2 was in front of our integral, e to the x, x minus 1. And then multiplying this all out, we can factorize out an e to the x, and we have the polynomial x squared minus 2x plus 2. And that's the final answer. And we can look at another example, a slightly more challenging example. Again, using integration by parts, evaluate the following definite integral, and the integral is the integral of sine of x e to the x. And you might think, well, I don't know how to solve this, because usually I differentiate the polynomial section so that it gets simpler and integrate the other bit. But actually it doesn't matter which bit you differentiate or integrate in this. So again, we identify u to be sine of x and dv by dx is e to the x. Then differentiating, we get du by dx is cos of x and v is e to the x. So we substitute this into the formula and we have the integral of sine of x e to the x with respect to x is sine of x e to the x minus the integral of cos of x e to the x with respect to x. And again, we have to use integration by parts. And it looks like it's going to carry on forever like this, but there's a trick. So we identify u to be cos of x and dv by dx to be e to the x. Then the derivative is minus sine of x, and the integral of this is just e to the x again. So let's just calculate the integral of cos of x e to the x with respect to x, and this is cos of x e to the x plus sine of x e to the x. And it looks like we have to use integration by parts again, but we don't. So let's write down everything we've got so far. So the original question was the integral of sine x e to the x with respect to x, and we've got that it's sine of x e to the x minus cos of x e to the x minus the integral of sine of x e to the x dx. And now notice that on both sides we have an integral of sine of x e to the x with respect to x. So we can actually add this on to both sides. So now we have two integrals of sine of x e to the x with respect to x, and this is all equal to, factorising out an e to the x, a sine of x minus a cos of x. So dividing by 2 gives us our final answer. So the integral of sine of x e to the x dx is 1 over 2 times e to the x, all times by sine of x minus cos of x. Thanks very much for listening.